Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here. 8 to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8 and log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer. Alright, so in this video, I'm going to be solving a system of equations. So in my system of equations, I have two equations. My first is AB plus A is equal to 32. So this is going to be my first equation. And my second equation is going to be AB plus B is equal to 35. So to solve this system of equations, I have to find the value of A and B. So to start out, what I'm going to do is subtract equation 2 from equation 1. So equation 1 minus equation 2. Equation 1 is AB plus A equals 32. So I have AB plus A minus AB plus B is equal to 32 minus 35. So to solve this, what I'm first going to do is distribute the negative sign. So now I get AB plus A minus AB minus B is equal to 32 minus 5, which is equal to negative 3. Now I can cancel out AB and negative AB, so I'm left with A minus B is equal to negative 3. And this means that A is equal to B minus 3. So now what I can do is substitute this value of A into equation number 2. So equation number 2 is AB plus B equals 35, right? Well, now that I've got a value of A in correlation to the value of B, I can plug this in. So now I get B minus 3 times B plus B is equal to 35. And now my only variable in this equation is B. So we can solve this. What I'm first going to do is distribute the B. B times B is B squared, and B times negative 3 is negative 3B. Now I have this plus B, which is equal to 35. And negative 3B plus B is equal to negative 2B. And if I subtract 35 on both sides, I get B squared minus 2B minus 35 is equal to 0. Now from here, what I'm going to do is actually add this back because we did miss a step. So B squared minus 2B is equal to 35 once again. Actually, before doing that, what I'm going to do is add 1 on both sides. So now I have B squared minus 2B plus 1 is equal to 36. And now the reason I did that is because B squared minus 2B plus 1 is the same thing as B minus 1 squared. And now I can take the square root on both sides because the square root of 36 is a whole number. And now I get B minus 1 is equal to positive or negative 6. So this gives me two equations. I get B minus 1 is equal to positive 6, and B minus 1 is equal to negative 6. So for B minus 1 equals positive 6, I can just add 1 on both sides, and I get B equals 7. And for B minus 1 equals negative 6, I can again add 1 on both sides, and I get B equals negative 5. So now from here, I have to plug this back in to this equation right here, AB plus B equals 35. So if B equals 7, I get 7A plus 7 is equal to 35, meaning 7A is equal to 28, and A equals 4. So if A equals 4, then B equals 7. This is one solution to my system equations. And now if B equals negative 5, I get negative 5A minus 5 is equal to 35, meaning negative 5A is equal to 40, and A equals negative 8. So if B equals negative 5, then A equals negative 8. So these are my two solutions.